received this Waterbury kitchen clock for servicing. It's a family heirloom, purchased new by the current owner's grandparents. The case has suffered some neglect when it was placed out of service in a basement, under some leaking pipes, and now has water damage on the face of it here. This crazing and cracking in the varnish can be corrected. However, the white stain could pose an issue. It has penetrated the wood fibers. The moisture it was exposed to has also disbonded some of the glue used to hold the case parts together. Someone in the past took good care of this piece. Labor costs for hand-carved woods was too high, so the wood was steamed, then pressed to get these decorative designs. Wood is split here. It goes deep into the trim and is an old defect. Missing the locking pin here. These latches should always have a 2-point fastening system, or eventually they will spin loose like this. Missing the support bracket for the top. Nice original label identifies it as a Janeway model. Shows some recent loss with the clean wood next to it. Sold October 20th, 1900. Missing another wood support here. Glass and painted decoration is in excellent shape. Definitely a nautical scene with this serpent dragon on the left. Right side has the typical Art Deco design of that era. Pattern is stenciled with gold paint. This alarm mechanism makes it the deluxe model. They were offered for about 50 cents to have it added. Remove these hands, a brass nail, dial is held in with 2 screws. Movement is held in with 4 screws. Pendulum is highly decorative, made from cast iron, which is a more stable material than the pot metal pendulums. It's finished with gold paint, designed in a nautical theme with a mermaid on both sides of it. Nice decorative regulating nut on the bottom here. Backside is recessed to save on material. Nice feature here is this pressed slot to nest the suspension rod. It stabilizes the swing of the pendulum. The pendulum rod is oval shaped here and nests into oval slots in the bob. This helps prevent pendulum wobble. A nicely designed pendulum unit. Dial pan is steel, plated in zinc. This prevents rust. No signs of rust or abuse. It's in nice shape. Brass escutcheons show signs of wear. Wear on one side like this is from the movement being loose or misaligned in the case. It's from the key rubbing on it. The 2 fastener holes in the dial were punched instead of drilled. Here you can see where the operator almost punched a hole in the wrong location. On the front here, the punch almost went through. A punch press was used instead of drilling to increase production. Dial is in a distressed condition. It's made from heavy paper stock, then painted with a white water-based paint. Black numerals are printed. The paper used in these was high in acid. They don't age well. They end up yellowing, imploding, and falling apart with age. The white painted surface is missing in areas. Paper expands and contracts, and eventually pops the paint off. An experimental process back then that was destined to fail with time. The alarm setting dial and the alarm lever that activates the alarm mechanism. Gold gilt is in excellent condition. Backside of these has a cam with 1 low spot for the alarm lever to drop into. When the lever drops into the low spot on the cam, the alarm bell sounds off. The Waterbury signature. This lightly stamped 5 indicates the pendulum length the movement is geared for. To the untrained eye, this looks like a brass bushing here. This movement has steel plates that have been brass plated. Early experiments using steel plates found they wore the steel pivots out. So as a fix, oversized holes were punched in the steel plates and brass plugs were installed at all the pivot locations. Wear on some of the pivots here and there. This pivot has some heavy crud on it, some fingerprint damage, more fingerprint damage. Looking at the front plate time side pivots, it should have several bushings installed. Strike side should be bushed as well. Time side back plate pivots are so caked with gunk, it's tough to see all the wear. Strike side back plate pivots should be bushed. I've done a pre-cleaning to get rid of the thick oils to help with inspection. It's going to need several bushings on the entire movement to make it right. Time to dismantle. Some of these pivots have some heavy wear on them. Lantern pinion trundles have some wear, but are serviceable. This pinion is caked with dried oil mixed with dirt. It's acting as a thick grinding compound. Now that it's removed, you can see the heavy scoring left behind from the dirt. This clock spent its entire life in a generational family farmhouse in North Dakota, so it was exposed to many years of farm dust. There's many ways to stabilize a pivot in a situation like this. This is a wood steady rest. The wood doesn't leave any permanent marks on the arbor and works just fine. As long as the end result is acceptable, the sky's the limit to ways to do a task. A piece of pegwood to further stabilize the pivot, and it's ready to dress the surface. Adding some color to the pivot surface helps to know where the stone is cutting. Cut the high spots off first. Looking better. Dress the pegwood to a clean grit-free surface. Ready for some finer finishing. Now to dress this other pivot. I've used a wood faceplate and cut a groove to snugly fit the escape wheel. It turns the arbor nice and true. Same process as the other scored pivots. Very little to no pressure is used. Just let the stone cut on its own. No more black color showing, so it's ready to start polishing. They turned out great. Escape wheel cock is the only brass piece in these clocks that have a pivot hole mounted in them. I've installed the bushing, and as you can see, I left as much as the original oil sink as possible. Judging from the original wear in the pivot hole, this bushing should give over 100 years of use before it needs to be replaced. That is, if it's cleaned and lubricated from time to time. Time to do a fit check for the front plate. Front pivot fits good. Now to bush the rear plate and move on to the next. As I mentioned previously, this movement has steel plates. They've been triple plated. First with copper, then brass, and finally with gold. I've seen people knock these brass plugs out and bush directly to the steel plates. I wouldn't recommend this because the holes in the steel plates are not centered to the pivots. To keep things as original as possible, it's best to bush in a way to keep as much as the original brass plug as possible. Here you can see the wear damage in the pivot hole. Same scoring as here as the pivot had on it. It's worn the brass to one side. These oil sinks in these brass plugs aren't concentric to the pivot holes, so this must be taken into account when centering the reamed hole. Each worn pivot hole needs to be pulled to the center when final reaming is complete. For this worn hole, I'll pull the center using the reamer. Reamers only cut on one side, so a hole can be pulled to center easily by cutting on one side only until enough material is removed to be even with the worn surface. Just cut carefully away the material on the unworn side of the hole until it's flush with the worn surface, same as if a file was being used. Only the reamer is doing the cutting instead of the file. Once the hole is concentric and pulled to the center, then ream to full size. I use stress-hardened 316 brass to fabricate bushings. Always install from the inside of the plate. I put a slight taper on the bushing, and this locks it in place from the inside. Nice and flush with the inside of the plate. I'll put a slight flare on the outside for part of the oil sink. Looking good so far. Ream from both sides to fit the pivot. Deburr the sharp edges. Now to do a fit check. And the final test is to see how friction-free the wheel turns with several puffs of air. Nice and friction-free. Movement has been cleaned. The bushings turned out looking great. Installed with minimal disruption to the original oil sinks and brass plugs. A lot of these original brass plugs and oil sinks aren't centered to the pivot holes, just the way these steel plates were fabricated back then. Peg the pivot holes. Someone has used this E-clip to mount the count wheel. It's not the correct fastener for this application. It doesn't fit the brass groove correctly. The hardened steel will end up damaging the brass. Definitely too thick. Original intent was designed to have a locking clip that fit to the bottom of the groove. It should be a brass count wheel clip that has a locking tab that locks in this hole. Not having any count wheel clips and wanting to get this movement assembled today, I'll take a few moments to fabricate one. Just need a small piece of brass shim stock. Copper is too soft. Stress-hardened brass is what is needed. First step is to make a nice fitting pattern to work from. Looking good, transfer the pattern to the brass shim stock. I'll use this cutter for making some of the radius cuts. It's tapered on the inside, so it won't deform the brass on the outside of the cut. Just what is needed here. Form the locking tab. Form the curvature for the spring tension. Fits great. The right amount of tension and movement needed. Now I can continue to get this movement assembled. When assembling the strike side, I only find it necessary to clock 3 wheels to get the sequence correct. The count wheel, third wheel, and fourth wheel. The third wheel has 2 positions, 180 degrees from each other, that are identical. Mark these 2 teeth as a visual. Either one of these can be clocked to the middle of the fourth wheel pinion. The fourth wheel has 1 stop pin on it and needs to be clocked for correct sequence. This tooth needs to be clocked to the middle of the governor fan pinion. Time to assemble. I'll use this needle in a pin vise to clock the fourth wheel gear I marked to the governor fan pinion. Now install the governor fan, making sure the marked fourth wheel tooth is in the center of the governor fan pinion. All other wheels can be installed with no clocking needed. Some rubber bands to get a steady, gentle pressure on the plates. This prevents heavy scratch damage to the insides of the plates I see too often. One by one, they will gently fall into place. Free the mainsprings. Install the verge. Oil the movement. Movement has been running non-stop for over a week now, with no issues. The client found an identical case that was in excellent shape. Apply some finishing touches to protect the wood, and it'll be ready to install the movement. This case is in excellent condition. Quality original dial designs are not available, so I'll make a custom one. It'll be exact to the original, but with better materials that won't degrade with time. The dial's done. Just need to add this text to the bottom. Looks good. Now to get this old dial pan ready for the new dial. Remove this decorative center ring. It's held on with these 3 tabs. The tabs are thin and fragile and need to be handled with care. On the inside, the gold gilt is intact, just some small spots of dark oxidized brass showing through. On the outside, the gold gilt is mostly worn off, with a lot of dark oxidized brass showing. Now to remove these 2 keyhole escutcheons. I'll be using some fishing line for removing them. They could be removed using steel tools like a screwdriver or sharp knife. These will leave tool marks, damage the zinc coating, and eventually show signs of rust. I'd rather use a non-destructive process. Any type of tool softer than the zinc plating will work. Brass used is thin, and this fishing line works just fine. Nice. No unsightly scratches and gouges in the zinc plating. This one can be removed safely using this wood tool. No damage to the zinc plating on this side either. Dial came out looking great. I used archival acid-free paper printed on a high-end laser printer. Modified this compass to cut circles by installing an X-Acto knife blade in an old pencil. It cuts nice, precise circles and is quick to set up. Get this dial located before attaching. Use an acid-free water-based adhesive. After it's dried, it can be finish trimmed. I sealed the paper with clear coat for protection against dirt and oils, and will be able to use cleaners on it. Install the decorative center ring. Find some keyhole escutcheons. These will work. Just install and flare the tabs on the back side to lock them in place. Looks good. A big improvement. It's going to look nice in the case. Oil the alarm assembly. Alarm assembly is held in with 3 screws. Install the alarm bell. The movement. Dial. Now that's an alarming alarm. Wake the whole house up. The movement was missing this rod, so I fabricated a new one and installed it. It manually advances the strike mechanism if it needs it. It's connected to this lever that lifts the count lever away from the count wheel. To finish it off, I'm going to fabricate a brass knob for it. This gives it a nice finishing touch, a nice Waterbury kitchen clock. ready for many years of keeping time.